Friends, very good morning to everyone. We have dealt with the reactions of carbocations. We know that it reacts to give addition reactions, substitution reactions, elimination reactions, and rearrangement reactions. Substitution reaction is one reaction which has been dealt with interest. Why it has been dealt with interest? It is because of the fact that some of the alkyl halides react with a nucleophile to give rise to a corresponding substituted product. Few of the alkyl halides follows first order kinetics, few of them followed second order kinetics. Why is this difference? What might be the reason? To know this reason, the two mechanisms have been put forward. They are SN1 mechanism and SN2 mechanism. To know the difference between the kinetics of the reaction in among the alkyl halides, two mechanisms have been put forward. SN1 and SN2. SN1 stands for substitution nucleophilic unimolecular reaction. What it indicates is that the rate of the reaction rate is equal to K into RLG. LG is the leaving group, R is the alkyl group. The rate of the reaction is dependent upon the concentration of the alkyl halide. Though nucleophile and alkyl halide reacts, the rate of reaction is dependent upon the concentration of only the substrate, that is alkyl halide, not on the nucleophile concentration or its strength. Why is it so? To know that or to explain this kinetics, SN1 mechanism has been put forward. It says that it undergoes reaction in multi-steps. SN1 mechanism is thus a multi-step mechanism. In the step 1, the leaving group leaves the alkyl halide. This is a slow reaction step and it is also a rate determining step. Once it leaves, it generates a carbocation as an intermediate. Rx dissociates into R plus and X minus. R plus is the carbocation form. In the second step, as R plus, the carbocation, as we know, it is a very reactive species and highly unstable species. Immediately, it reacts with Z minus, that is the nucleophile, and it gives rise to RZ. The X minus in Rx is replaced by Z minus to give RZ. And this is a rapid reaction and it occurs within no time. Immediately, as soon as the carbocation is formed. That's why these carbocation intermediates are non-isolable. Yes, it is something like this. The SN1 mechanism is like rowdyism. How the rowdies are killed. When they are alone, when they do not have any bodyguards, they are attacked. The evidences were given in support of the mechanism proposed. One evidence is the polarity of the solvent. If we go on increase the polarity of the solvent, it also increases the rate of the reaction. It's because of the fact that when there is the increase in polarity in the solvent, It can increase the ionization. When ionization is increased, carbocations are formed more easily. More easier the carbocation formation, more is the product formation. It indicates that the carbocation is formed as an intermediate in the reaction. Another evidence which was given in support of the SN1 mechanism is that the tertiary alkyl halides are more reactive than secondary alkyl halides, are more reactive than primary, or more reactive than simple alkyl halide. This has been attributed to the fact that the carbocation is the intermediate formed, and we know that tertiary carbocations are more stable than secondary carbocations, are more stable than primary, are more stable than simple carbocations. It is attributed to the positive inductive effect and the hyperconjugation effect of the by the alkyl groups present on the carbocation. More stable the carbocation, more easier is the formation. That's why tertiary alkyl halides will be more reactive as it forms tertiary carbocation. It in turn indicates that carbocation is the intermediate formed in the reaction. Carbocation, as we know, it cannot be isolated, but we can give the indirect evidence that carbocation has been formed in the process of the conversion of the starting material to the product. If the living group can easily leave, more easily the carbocation is formed. In alkyl halides, alkyl iodide is more reactive than alkyl bromide, is more reactive than alkyl chloride, is more reactive than alkyl fluoride. Because iodide is more easy living than that of bromide, is more easy living than that of chloride and that of fluoride ion. In turn, it indicates a carbocation is an intermediate formed in the process of the reaction. If I take the nucleophilicity of the nucleophile do not affect the rate of the reaction because it is not involved in the rate determining step. Means it indicates that the reaction takes place in two steps and the nucleophile is not involved in the rate determining step, and thus way the strength of the nucleophile do not have any effect on the rate of the reaction. Thus it is an indirect evidence that the two steps reactions takes place and the carbocation formation is the first step. Further, the stereochemistry of the reaction is another evidence which is given in support of SN1 mechanism. There is loss of chemistry, stereochemistry, and it gives 88% of racemic mixture and 12% of the inverted product. When the carbocation is formed, the nucleophile can attack from front or from back. When it attacks from front, it gives one type of isomer. When it attacks from backside, it gives another type of isomer, which is the mirror image of the first one. As equal opportunity to attack on the carbocation formed, it gives a racemic mixture. If that is the case, it would have given 100% racemic mixture. But it has given 88% racemic mixture and 12% inverted product. Inverted product is formed when attack takes place from backside. When attack takes place from front side, it gives a normal product. Why? How can we explain this? It is explained like this. Rx, alkyl halide, it dissociates to form the ionized product R plus and X minus. It directly do not get ionized. First, it forms an intimate mixture. The carbon and halogen bond slowly breaks. Once it slowly breaks, the alkyl group gets a slight positive charge and X gets the slight negative charge, and still the bonding is there. It is not completely separated. This stage of separation before the complete separation is called as intimate mixture. Then slowly the solvent molecules come in between these two and they separate them to give a complete ionized product. Means the attack takes place as soon as the positivity occurs on the R. When the attack takes place now from the back side, as from the front side there is X minus, and X minus and Z minus both are negatively charged and like poles repel each other. Hence, backside attack takes place. And then, once this ionized product is formed, the attack takes place on from backside and the front side equally. That's why it gives 88% of racemic mixture, and the attack on the intimate mixture when it takes place from backside, and that's why it gives 12% inverted product. Another evidence which is given in support of SN1 mechanism is formation of rearranged product. Propyl chloride, if I take, it can dissociate into propyl cation, which is a primary carbocation. As we expect, Z minus or any alcoholic group OH minus can attack to give a propyl alcohol, N-propyl alcohol to be precise. But however, it do not give the N-propyl alcohol. Instead of that, it gives a secondary alcohol, that is 2-propanol instead of 1-propanol. It is attributed to the fact that before this nucleophile come and attack on the primary carbocation, it gets converted into secondary carbocation by 1, 2 hydride shift to give a secondary carbocation. And on this formed secondary carbocation, the OH minus attack to give 2-propanol. The 2-propanol formation indicates that the secondary carbocation is formed, in turn indicates that a carbocation is an intermediate form in the reaction. These are the evidences which are given in support of SN1 mechanism. Another mechanism put forward to explain the bimolecularity of the alkyl halides is SN2 mechanism. That will be the subject of discussion in the coming classes. Thank you.